Good morning, students. Next chapter is mathematical logic. In this chapter, you will get 1 mark, 2 marks, and 3 marks questions in the final exam. Okay. In this, first one is proposition. First, we should know the definition of proposition. Okay. Proposition and statement both are same. Okay. See, one difference is proposition means an assertive statement which is either true or false but not both at the same time is called a proposition. See, if we consider any statement that is either true or false but not both, okay, then that statement is considered as proposition or statement. Okay. See, for example, consider 5 is a prime number. 5 is a prime number. See, the statement is true. Suppose consider second one, oxygen is a gas. Of course, oxygen is a gas, therefore it is also true. See here, third one, 23 by 2. 23 by 2 means that is 11.5 less than or equal to 5. See here, 11.5 is greater than 5. Therefore, this is false. First one is true. Second one is true. Third one is false. Next, consider fourth one. Root 2 is an irrational number. See, root 2 is an irrational number. 2 is a prime number. Square root of any prime number is an irrational number. Therefore, it is also true. First one is true. Second one is true. Third one is false. Fourth one is true. Next, consider fifth example. The word logic has 5 vowels in it. See here, in logic. Okay. Logic is the word has 5 vowels in it. See here, it has only 2 vowels. Therefore, the statement is false. Okay. These are all called as propositions. See, the statements is true or false. Only one value it has. Therefore, these are called as propositions. Suppose consider examples here. Example 1. Weather is pleasant today. Weather is pleasant today means we cannot predict the statement is true or false. Suppose one day may be pleasant. Okay, like that. Suppose today means we can consider today. Suppose Sunday, Monday, Tuesday, like that we can consider any day. We cannot predict exactly. Okay. Sometimes this statement is true and sometimes this statement is false. Therefore, we cannot predict either true or false. Therefore, it is not a proposition. Next, consider wish you good luck. See here, you contain exclamatory mark. Okay, it is also not a proposition. See here, the sentences involving questions, exclamation and expressions of opinion are not considered as proposition. We cannot predict that is true or false. Okay, the sentences involving questions, exclamations and expressions of opinion are not considered as propositions. Okay. See a third example. How old is this building? See, how old is this building means that is a question. This building means we can consider any building. Okay. Therefore, it is not also not considered as a proposition. See next one, fourth one. Hurry, we won the match. Okay. This is also exclamatory statement. Therefore, we cannot consider as a proposition. Okay. See here. First, you have to understand which is proposition and which one is not proposition. Proposition means it has either true or false but not both. Okay. Next, questions. The sentences involving questions, exclamations and expressions of opinion are not considered as propositions. This is for some example. He is a doctor. He is a doctor means he refers who? Right. Therefore, he is a doctor is also not a proposition. Okay. Next, see here, the truthness or the truthness or falsity of a proposition is called truth value of the proposition. If either a statement is true or false, that is considered as truth value of the proposition. Truth value of a true proposition is considered as T. T means that is a truth value. Okay. False proposition is considered as false. Truth proposition, false proposition. If a statement is true, then that is truth proposition. If a statement is not true, then it is a false proposition. Truth is denoted by capital T. False proposition is denoted by capital F. Okay. Next, logical connectives. So before going to logical connectives, you should know the definitions of simple proposition and compound proposition. There are two types of propositions, simple proposition and compound proposition. So simple proposition is a statement which cannot be split into two or more statements. Simple proposition is a statement which cannot be split into two or more statements. Which means what? It contains only one statement. See, for example, set of natural numbers is finite. It is only single statement. We cannot split into two or more. Next, second example, New Delhi is in India. Okay, these two statements cannot be split into two or more statements. Therefore, these two are considered as simple proposition. Next, compound proposition. See, compound proposition is made up of two or more simple propositions called its components. See, a compound proposition contains two or more statements. Each statement is considered as a component statement. See, for example, first one, if X belongs to A, comma, Y belongs to B, then X belongs to A union B. So here it contains two statements. First one is X belongs to A. Second one, Y belongs to B. Consider this as one statement. Second statement is X belongs to A union B. It contains two statements. These two are related by if and then. See, if first statement, then second statement. Okay. These two are called component statements. Okay. So here, if X belongs to A, Y belongs to B, then X belongs to A union B. Here, X belongs to A, Y belongs to B is a proposition, and X belongs to A union B is another simple proposition. Okay, it contains two component propositions. See, next one. Mathematical is easy or it is not raining today. Here also we have two statements. First one is mathematics is easy. Next one, it is not raining today or it is raining today. See, mathematics is one statement. It is not raining today is another statement. These two are combined, then compound proposition. Separately we can call it as a component statements. These two are connected by or and not. Okay. See. Next, the words can be used to link the two or more component statements are called logical connectives. Here, these kind of words that are used to link two or more simple propositions to form a compound proposition are called logical connectives. See, in the first example, two statements are connected by if, then. In the second statement, two statements are connected by or and not. See, these are all called logical connectives. Okay, we have 5 logical connectives. See here, the 5 logical connectives are first one and, second one or, third one not, fourth one if then, fifth one if and only if. There are 5 logical connectives and, are, not, if then, if and only if. Okay, let us study one by one. First one, and. And is called as conjunction. Conjunction means and. Okay, it is denoted by like this, reverse V. Okay, conjunction means ulta V. See, if P and Q are two simple propositions, then the compound proposition of P and Q is denoted like this, P conjunction Q. This is called as conjunction, P conjunction Q. Okay, the truth values of the compound statements. Okay, the compound statements connected by and. Then the truth values see are, if both the values, suppose P and Q are two statements, are two connecting statements. Suppose first statement is true and second statement is true, then only P conjunction Q is true. If both the statements are true, then only the compound statement is true. Suppose first one is true, second one is false, then it is compound statement is false. Suppose first one is false, second one is true, then also it is false. If both the statements are false, then also false. Okay, if both the statements are true, then only compound statement is true. So here they are given, the truth value of the compound proposition P and Q is true if both the components of P and Q are true. In all other cases, it will be false. This is written in the form of table here. Okay, this table is called as truth table. Okay, see the possible values, possible combinations here, P and Q. True, true, false, false, true, false, true, false. See, in first case, both are true means true. In all other three cases, it is false. Okay, you have to remember this one. For example, first one, consider two statements P and Q. P is, E is an vowel, Q 3 plus 4 equal to 7. Suppose these two are connected by conjunction. Conjunction means what? And. Okay. See here, P is true, Q is, first consider this statement. If E is an vowel and 3 plus 4 equal to 7. E is an vowel, this is true. 3 plus 4 equal to 7, true. P is true, Q is true. Therefore, P and Q is also true. Suppose first statement is E is vowel. Second statement is 3 plus 4 equal to 8. See here, first statement is true, second statement is false. Therefore, the combined statement is also false. If both are true, then only the compound statement is true. Otherwise, false. This is about conjunction. Conjunction means and. It is denoted by V, reverse V. Okay. Next one, disjunction. Disjunction. See, disjunction is denoted by V, V symbol. Okay. Disjunction means R and denoted by this symbol. Okay. Two simple propositions P and Q are connected together by the word R is called the disjunction of P and Q. It is denoted by like this. Sorry, this is V, right? P V Q. V means that is disjunction. Okay. Two simple propositions P and Q are connected by the symbol R. These are called disjunction. It is denoted like this. Okay. Next, consider the truth values. See, suppose P, Q, P, R, Q. Okay. See, suppose these are the possible true, true, false, false, true, false, true, false. Like that we can write. Okay. See, in our statement, if any one of the statement is true, then the compound proposition is true. See, in first case, both are true. Therefore, that is true. In second case, first one is true, second one is false. Therefore, it is true. If any one statement is true, then compound statement is true. In last case, both are false. Therefore, compound statement is false. If both the statements are true, then only compound statement is true in case of conjunction. In case of disjunction, if any one of the statement is true, then the compound statement is true. Otherwise, it is false. Okay. See here, the compound proposition P and Q is false when both the components are false. Only one case you will get false. In remaining three cases, it is true. Okay. For example, let P root 2 is irrational, Q 9 is a prime number. Okay. So here root 2 is irrational. First consider the compound statements P or Q. P or Q means what? Root 2 is a irrational or 9 is a prime number. P is a true proposition. Root 2 is true. P is true. Q means 9 is a prime number. 9 is not a prime number. It is a composite number. See here, first statement is true. Q is false. Therefore, P conjunction P disjunction Q is true. Because first statement is true. Next, third one is negation. Third logical connective is negation. The negation of a proposition P is not P, means that is reverse of a given statement. Suppose mathematics is easy. Negation means mathematics is difficult. Like that. Opposite. He is a doctor. He is not a doctor, like that. But these are all not statements. We cannot consider these are examples. Okay. See, suppose root 2 is irrational. Negation means root 2 is not irrational. That is called the negation value. See, the negation of a proposition P is not P. Denoted like this, negation P. Okay. Suppose the given statement is true. Negation P will becomes what? Suppose P is a statement, negation P. The given statement is true. Negation means it will becomes opposite, that is false. Suppose the given statement is false, the given negation is true. Like that, this is the truth table for negation. See here, calculus is difficult. Negation P is calculus is not difficult. Okay. See, the truth table for negation is P, negation P. If P is true, negation P is false. If P is false, negation P is true. Just opposite. The negation of a proposition is obtained by using the word not. Okay, in the appropriate place. Just you have to add the not. Root 2 is rational. Root 2 is not rational, like that. We can add not.